Here today, we have with us Brian Turner, who is most famously a giant geek. We've heard that you have worked with a program known as Space Pirates. What did that entail?
So the Kansas City Space Pirates is a technical competition team. We entered a NASA competition called the Space Elevator Games. The process we were working on is how to power the space elevator. So we worked with lasers powering robots remotely.
A laser begins with the excitation of electrons. This raises the electron to a higher energy level, and when it drops back down, it releases that energy as a photon. Due to a quantum process known as stimulated emission, when a photon excites an electron, the photon released by that electron is almost identical to the incident photon. The waves are concurrent, meaning the crests and troughs all line up. The electrons are excited in a box with two mirrored walls. Any stray photons are absorbed by the other walls, but some are reflected off the mirror, exciting more electrons between them and causing the waves to undergo constructive interference. This wave eventually escapes through a tiny hole, creating a laser beam. So, a laser is light amplification by stimulated emission of radiation.
And has that led to anything in your career?
It's made me really well qualified to be a mentor at the local robotics team. It creates an aversion response. Do you guys know what that aversion response would be? Pain.
It's
emergency.
but
So they will only burn the surface of your eye.
They'll only burn the surface of your eye.
Yeah.
Alright, I'm here with application for lasers. One use for lasers is in the Navy. In 2014, a laser was deployed on the USS Ponce. Now this laser used a pulse system. It fired once to try to destroy a drone or something like that. This costs about $1 to fire once, while some of their larger weapons cost hundreds, maybe thousands of dollars to fire once.
Maitland, what are we going to be
We
doing?
gonna burn some paper.
I put an additional lens on the laser to bring it to a focal point out here in front. So beam on in 3, 2, 1. There it is. There's the focal point. Beam off.
When Dayton explained how a laser works, he said that electrons get excited. The only thing he didn't mention was where the electrons originally come from. This is called the gain medium. The gain medium can be in any state: solid, liquid, gas, and even plasma. It is kept in between the two mirrors inside the laser. If the gain medium is changed, then aspects of the laser are also changed, including the color. One of the most common gain mediums is a gas. A carbon dioxide laser operates at 10,600 nanometers and is in the infrared. A helium neon laser operates at 633 nanometers and appears orange to our eyes. One very special kind of gain medium is actual living cells that have been genetically engineered to have the GFP, which is a green fluorescent protein found in jellyfish. This operates at 510 nanometers and is green.
So, to demonstrate the difference between visible wavelengths and infrared wavelengths, I'm going to show you the difference between a visible camera and a thermal camera. So, you're looking at me now with the visible camera, and when I put a trash bag in front of me, you can't see me anymore. But if we're looking at an infrared camera that sees in the 10 micron range, now you see me, and you still see me straight through that same trash bag. That's because this material is transparent to the 10 micron wavelength. Humans, we emit light at about the 10 micron range. Most of the stuff we see around us is about 10 microns where it emits energy. That happens to also be the wavelength of the typical CO2 laser. Without.
So scientists have recently come up with a really cool way to harness solar energy. Now this would involve sending a satellite into outer space with both a solar panel and a laser attached to it. Now, the solar panel would absorb solar energy from the sun, and then it would send it back down to a solar panel on Earth via the laser. This would allow us to have massive fleets of solar panels in outer space, all receiving very direct sunlight almost all day long, while only having to have one solar panel on Earth.
Also at the Turner household, I have with me Rafiki, a leopard gecko. So, do you know anything about lasers? Wow, thank you. That was very informative and interesting.
Today we have Maitland holding a weather balloon in front of a laser.
I'm really scared.
Don't be scared.
Okay.
Just gonna break your hand.
What?
If it hurts, scream. It'll be great for the video.
Nice.
All right, beam on in 3, 2, 1.
I'm still really scared.
Just going through. I gotta be able to see that beam. All right, so we hit this thing with 108 watts of energy, and it went right through it. Did not burst the balloon. So we used a Sharpie and put a black target on it. We think that'll change the odds against the balloon's favor. Beam on in 3, 2, 1. Beam on.
Oh! Oh! Oh!
Say that because that's technically inaccurate, which is not something I do. You guys said you're graded on it being technically correct.
We have to be accurate.
Yeah, but heat doesn't count.
And about the physics part.
Okay. This is the brass part. It gets hot. It has a lot of heat. And they then tune it so it can handle the heat. Then it doesn't turn back into heat.
If you were cutting metal with this, how much heat would be generated?
100 watts.
So like 98 heat?
Actually more along the lines of 80.
80 heat, okay. 70 heat or 30 heat?
30 heat.